Hi, this is Paul, City Sailing. Welcome back. In this tutorial, we're going to talk about how to fix your position. We've got plenty of City Sailing tutorials, and this one is on fixing your position. Right, let's have a look. Let's get in there. Okay, when you fix your position on the chart, the symbol is a dot and a circle, and what you do is you put the time next to it and also your log reading. So, position by a simple fix. So, one of the simplest fixes is to when you get next to a known object, such as this buoy here, even better if it's named, you know where the buoy is, look on the chart, and that's where you are. So if you're sailing around the Solent, there's no excuse of getting lost. Go up to the nearest buoy, read the name, that's where you are. So if we can do a position fixed by a compass bearing, we use a hand bearing compass. So we look down the hand bearing compass at fixed positions. So to do that, we'll need 3 bearings. We need to identify on the chart the objects that we're looking at. We plot the bearings. So we take them with a hand bearing compass. That will be magnetic. Convert them with variation to true. If that means nothing to you, go back to our other tutorials and we'll explain how to apply your variation. It's a tutorial called compass. So apply the variation, put the lines on the chart, and hopefully they'll cross like they have in this diagram, and we put a dot and a circle round. So choose objects that give good bearings. We've got 60 degrees apart, that's great. If they're close together, you'll get a bad angle of cut and it's harder to do. So due to the movement of the boat, inaccuracy of the bearing produces an inapproximate fix. So if we take a little bit of error on each of them, so there's a little bit of error on all of them, so it gives us a point of error on our fixes. So although they're great doing 3-point fixes with the hand bearing compass, but just bear in mind it's not going to be spot on the money. There's going to be a little bit of error there. So most compass fixes produce a triangle called a cocked hat, and you'll be somewhere in that triangle. If there's danger nearby, you always assume that your nearest point of the danger. So here we go, they're not quite there. This bit in the middle is called a cocked hat. So we take our assumed position to be closest to the danger, and we'll navigate from there. So before you take your bearings, we're going to plan our bearings. So pre-plan the objects you're going to use. This may sound daft, but make sure that the objects you're taking bearings on are the objects on the chart. It's really easy to kid and convince yourself that what you're looking at is what you want it to be on the chart. So make sure it does line up with the chart. Planning the bearings, you know roughly where you are on the chart, so plot rough bearings on objects to identify them. So here we can see the lighthouse, and we're taking the bearing of the lighthouse. It's actually North Foreland Lighthouse. By night, it's easier to pinpoint because the lights will pinpoint. If you've got a hand bearing compass, just give a little shine with a torch without looking at it, and that will energise the bit in the middle and you'll get that glow, so it's easier to see. Don't look at the torch because you'll lose your night vision. So planning the bearings, buoys can move in storms or at low water. So between high and low water, the buoys will move. So they could be slightly out, and again in storms they could move. So planning the bearings, use objects if possible to give you a good angle of cut. So now we're on to taking the bearings. So keep the compass away from any metal or wiring or your glasses or mobile phone zips, harnesses, etc. Otherwise that will affect the bearing on the compass. So take the bearings, take the bearing on the beam last. So the one that's changing quickest, you take last. So here you would take church first, chimney, flagpole. Because in the time you've taken to take the church and the chimney, you'd have moved from here to here. So if you'd done this one first, it would give you this position, but actually by the time you've done it, you'll be in this position. So in short, take the bearing on the beam last, take the bearing of the one that's changing quickest last. So taking the bearings, take bearings as short a time as possible, call out the bearings to crew member and get them to write them down and plot. So you take them on deck, shout them down, somebody else plots your bearings. So you take the bearings, you top your part of your body free and counter the motion of the yacht, especially in rough weather. You roll around, so brace yourself and practice taking the bearings. Keep the compass horizontal and allow the compass card to settle down. You can take your position by transit, which is two things lining up. So here we've got these beacons going into a harbour. When these two line up, it's called going into a transit. So here we go on the diagram. We've got this the chimney and the what's called a perch, which is a stick with a symbol on top. Line these two up, and when they're lined up, they're in transit, and they can be identified on the chart. So transit one of the most valuable tools when closing dangers on the land. There's no compass variation or deviation. They can be used when the sea is rough and it's difficult to take a compass bearing. They're instantaneous and can be monitored continuously. They occur frequently when in confined waters when you're doing pilotage. So here we go. It's quite a skill here to look at the chart beforehand, look where you're going beforehand, and draw on or imagine transits that you can use for your passage, or transits that you can use that will keep you away from danger. So if we look here, we can see the natural transits. So view from A, the headland is just open and it's the line A. View from B, the headland is quite open, which is the view from B. If the headland was dead in line, we'd be on the transit on the red line there. So you could use a natural transit to keep on your course. So look ahead, find two objects that line up on the course you want to steer, a building, a house, or tree, as long as they remain stationary. When they remain in line, you're on the intended course. So on the picture below, we've got the tree and the house. They keep in line. We're on our intended course. On the left hand, we'll need to turn to starboard. On the right hand, we'll need to turn to port. So transits. Many areas with tricky pilotage problems have a series of transits readily set up to assist mariners. So we've got one here. We've got transit abeam. So we're 90 degrees to that pole. We know that we're abeam of that pole. And we've got the beacon and the house lined up. So when we do our pilotage plans, we need to look at possible transits to help us with our passage. So transit and leading marks. So there could be a transit going into a harbour that's marked on the chart. Here there's two posts on our chart. And the first, they're both licks. They've got the magenta teardrops. The first one says a colting every 4 seconds. 12 big M, which is 12 miles nominal range. So if the visibility is 10 miles, we'll see that light for 12 miles. And the one in front of it, which is lower, is a colting red every 4 seconds, 10 miles. And if we line those two up, it actually tells you on the chart that the bearing of that is 269 degrees true. So we can use a sectored light. So we've got the fixed green, fixed white, fixed red. I know we covered this in the buoys and lighthouses. So if we're on the edge of the sector, as we go from left to right, it will go from the colour. So if we're between the red and the white, if we're weaving between the two, it will go from the colour of the lighthouse or flash going from the red and the white, and we know we're on that line. And here we go, sectored light diagram. On the left hand, we've got the vessel in the red sector. Just below it, you'll see it will just see a red light. On the middle one, it's in the white sector, and you'll just see the white light. And on the right hand one, if you're the green sector, you will just see the green light. So whichever sector you're in, you will see that light. And as I said before, if you weave in between, say, the red and the white, you know you're on the line between them, and it's quite an effective way of knowing your position line on the chart. And here you can use sectored lights to navigate. So, a bit of electronics here, knowing your position with electronics. So we can use depth. Depth is great because it's coming from your boat. So the information is coming from your boat. What happens is that it pings the bottom, pings back, measures the tire, measures the depth. A few things the Echosender doesn't like. One is fine silt and mud. It struggles to find the bottom. It doesn't like air bubbles. So if you've gone behind a ship's wake, it will go all funny and obscure. And that's because it's bouncing off the air bubbles. But if you've got a steep shelving shore, it will give you a good position because you'll be able to work out a contour. If it's shallow shelving, it's really hard to work out a contour, so it's not as useful. So we can give a position with a bearing and a depth. So we've got the bearing of the radio masts, and depth is 30 metres, allowing for the height of tide. So when we talk about how to contour with height of tide, we'll need to go to the tutorial, the city sailing tutorial on tidal heights. So depth 30 metres, allowing for the height of tide. bearing a 080 degrees from the boat, and that will give you a position fix with a bearing and a depth onto a contour line. So we can get forward-looking echo sounders, which shows what's coming up ahead. It's great to identify shallows and depths ahead. But obviously, if you've got a normal echo sounder, it only tells you what's happening now, not what's in front of you. We can use position by radar. We love radar. We do the RYA Radar one-day course, so I'm going to give you a smidgen here on the radar. If you want to know about navigation and collision avoidance, and especially Rule 19 collision avoidance when you're in the fog and you can't see the other vessel, there's a one-day full radar course, and we can talk about that. So how does the radar work? Well, it's got a magnetron in it, and it sends a pulse of microwave energy, reflects any targets above sea level, and it bounces back, and it then projects those images of the energy that's bounced back onto your screen. So big solid objects reflect a pulse better than small wooden boats or GRP, which is fiberglass. Creating pulses of microwave energy require higher power. So most small boats, the radars are about 2 kilowatts, so it's quite a lot of power. Screens, so it could be an LCD screen like this, or you can have one that overlays with your chart plotter. Beam width. So on a yacht radar, the width of the beam is about 5 degrees. On a military grade, it will go down to about half a degree, which gives you much better definition. But on a yacht one, it's about 5 degrees. So what that will do is extend the headlands, and some things will we won't be able to see. So a small inlet we won't be able to see. So we'll go a load of detail in that in the City Sailing RYA radar course. We'll hopefully see on one of those courses. We can put bearing lines on, so we can move a bearing line from the front. It's called electronic bearing line, or an EBL. So we can work, and that will be relative from our bow. Or we can do a variable range marker, which is just a ring that we go in and out on our range marker, and we can work out distance off. Distance off with the radar is pretty accurate. So if we measure 3 distances off, get our pencil compass, and we can do arcs from the land, and we can arc it off and get our position. So with the radar, we can double up our position and check it against the GPS and our visual by using distance off. Here we go. So what we're doing here, we've got A, B and C. We've done the distance off, we've marked it off, and that gives our position fix. So the position fix again, dot and circle, that's where we are. So automatic identification system. This works on your VHF signal. So we've got the AIS. It transmits our position. We've got a screen, and we can get other people's positions. So on the screen, we will see where the other vessels are and what they're doing, and they will see our vessel as well. So on this chart, we can overlay it onto a chart plotter. So here we go, the other vessels, and it will tell you their MMSI number. If that means nothing to you, tutorial on VHF. So we've got a tutorial on VHF, and we'll explain what an MMSI number. Closest point approach, closest it's going to get, speed of the vessel, direction of the vessel, and we can get the time of the closest point of approach. So it will give us the information on the other vessels around us with the AIS. GPS uses a constellation of 24 satellites orbiting 11,000 miles above the Earth. So to get a fix, we'll need 3 satellites to a given position, and the position is shown in latitude and longitude. So latitude and longitude we've explained in our earlier city sailing tutorials. So from the position, we'll get latitude and longitude, and from this the GPS can calculate your position by latitude and longitude, course over the ground, sometimes known as COG, speed over the ground, SOG, distance to a waypoint, which is the range, bearing to a waypoint, time to go to the waypoint, cross-track error, which we're going to explain in a minute, and velocity made good, which is VMG, which is really important to racing people. So on your GPS, here's a handheld one. We can get position in latitude and longitude, and it will give you the strength of the satellite signal, and it will show you where the satellites are and the strength for getting them. There we go. This is where the satellites are. So if you look straight overhead from that arrow, I will see where the satellites are, and it will give the horizontal dilution of precision, and that will give you the accuracy. So what that means is if the satellites are a good cut, say 60 degrees from each other, we'll get a good intersection on the line, like a position fix. If they're close to each other, we'll get a poor, because the lines are too close together, we'll get a poor fix, and the H-stop will give us the accuracy of the fix. So it'll either give us an H-stop number or an accuracy on our GPS. Cross-track error. So if we were to draw a line from where we're starting to where we're going, the cross-track error is the distance we're off to one side of that line, sometimes called XTE. So here's cross-track error, tidal stream take here. So from here, this is our cross-track error, this is our cross-track error, this is our cross-track error. Velocity made good. So if we're going in the direction of this arrow and we're going into the wind, we've got a long tack, short tack, long tack. So this tack here, we're getting to the destination faster than this tack. So this one here, we have a better VMG than this tack. So it's our velocity made good to our destination. So we've got display on the boat here, we've got cross-track error, track, distance of the waypoint, and bearing of the waypoint. So GPS, we can interface that. So GPS can be interfaced with a variety of electronics on the boat, chart plotters, electronic charts, and radar, to provide a visual position on the chart or radar with autopilot to steer the boat. So here we go. We've got our computer software on the boat, and the interface with the GPS will give our position of the boat and our actual track of where we've gone. So with the GPS, we're going to be aware of problems and errors. So we can't rely on it wholly and 100%. So it's generally pretty reliable, but as with all radio signals, can have problems and affect its accuracy. So human error, if we put the wrong information in, or we've read it wrong, or we've got the wrong data, it's going to be wrong. Power failure or fluctuations, particularly with batteries and handheld sets. We've got power failure, be problems. Sighting of the aerial. The aerial needs to be low down. If you stick it on the top of the mast, we've got what's called signal bounce. It'll go to the water, come back up again. It's aerial low down. Problem with the aerial low down is that you'll find crew members will sit on it, or examiners will sit on it, and if you sit on it, the GPS won't give a position. So we get interference from other transmissions, such as radio signals or mobile phones can distort the signal, and also sunspots or solar flares can damage the signal from the GPS. So you need to always check your GPS position using another method and plot it on the chart. So don't rely wholly on your GPS or your plotter. So using GPS for navigation. GPS uses waypoints for navigation. Waypoints are stored latitude, longitude, or you can put your own waypoints in. So here we go, plotting the range and distance. So all we've done is we put a waypoint in, into the center of the compass rose, and we can get our position by looking at the GPS to the waypoint. So the bearing is 240. So we can put 240 on here, draw the line out, and measure the distance 3 miles. So if the bearing to the waypoint is 240 degrees 3 miles, 240 through the middle, out the other side, because it bears 240 from us. So there's 0, 90, 180, 270. So from us, 240 is down in that direction. So the following methods to fix your position, useful for a fast motorboat or a rib, reducing the time below navigating. Great idea to prepare an overlay for the chart before you set out, and you'll need to prepare one for each scale, or do it beforehand on a laminate. I quite like laminating charts and using a permanent overhead projector pen, because that stays on, it doesn't wash off, and a fluid or alcohol will wash it off afterwards. So here we go, we can put on a waypoint here and draw like a spider's web waypoint and plot the position if the range of the waypoint is 3 miles and the bearing is 110. So 110 from the boat to the waypoint. So the bearing to the waypoint would be 290. So 290 we're on this line, 3 miles, 1, 2, 3. So it's quite easy to pop your boat onto that spider and we know where we are. So if you're on a fast boat or rib, it's quite hard to write down a latitude, longitude on the chart, and you have to look down for too long. Or we could do a cross-track error ladder. So this is where we're starting, this is where we're going, draw the line, section it off into miles and miles or half miles from the out. So the question is, plot the position if the range of the waypoint is 6 miles and the cross-track error is 1 mile. So 6 miles, 1, 2, 3, 4, 5, 6, and your cross-track error out is 1 mile, 1 mile. And we know that we're there, and it's quite quick and easy to plot ourselves on there. Thank you very much for watching our tutorial on fixing your position. City Sailing has lots of tutorials, and we really appreciate you joining them, and we'd like your feedback, so please like and subscribe. So hopefully we'll see you soon on another tutorial, or we'll see you on a course, and I look forward to seeing you. This is Paul. Thanks very much. Cheers. Bye.